All right, here's the start of a video on the water supply. So this is what I shipped you in the first box, plus a lot of other stuff too, but this is what I shipped you in the first box. Should arrive on Friday. So here's this header assembly, and actually I made it a little longer. You can see this little connection right here. It was a 6 and a 4 put together. It makes a 10. And what we've got here is, this way to the left would be the incoming water supply. 1 inch. This is all 1 inch piping until we get down here. It's 3/4, but this is the incoming water supply coming out of the that blue storage tank. Okay, so placement of this, we're going to have to work on. I haven't determined this yet. But what this is coming down here, and it can be shorter, this can be a shorter piece. And coming down here, we're at 1 inch, we reduced to 3/4, and we're at this ball valve here. And this is going to be the water supply into the hot water heater. So we place this on the wall to the left of the boiler hot water heater, and we can hook it up. Now, it could be the other way around. We haven't decided yet. So this is flipping it around and having the water to the boiler coming up from the top. But I do have to believe it's going to be this way. So there we go. Now, so all these are PEX fittings. This is cold water supply. That would be blue pipe. So blue pipe that you'd get at Home Depot or Lowe's. Now, it doesn't have to be oxygen barrier. It has to be PEX-A, but it doesn't have to be oxygen barrier. Oxygen barrier is only for the hydronic heating system. It's probably a little cheaper that way. But when you go into Ferguson, I learned something. I asked for PEX pipe there, and the simple question is it for plumbing or heating? Plumbing or heating? If it's heating, it's oxygen barrier. If it's plumbing, it's just not oxygen barrier. But we're using PEX-A because of these fittings with Milwaukee Tool to put them together. So now here's the picture of the crimp that I made. And you can see it's that crimp machine, and I did ship you that crimp machine. Here it is. I couldn't get it to ship to you direct, so it came to me. I wanted to cancel it completely, but it came anyways. And this is a picture of it. These arms extend, by the way, make it longer. But what I did on my very first crimp, I blew it. And that is, that crimp machine will do 1 inch, 3/4 inch, or 1/2 inch. So I put on the pieces that are supposed to do 1 inch. Well, I didn't look at the second one I put on, and it happened to be 3/4. So this is the very first crimp I made, and you can see this nick right here. I was 3/4 on the bottom side, 1 inch on the top side. So I kind of gouged into it. Well, it pissed me off, but I decided I'm going to continue on and here's a 1 inch, 1 inch. Here's the compress and fitting a proper compression. And I thought I'd leak test it. And it doesn't leak. So what I did is I put this thing on here right here. This is a hose fitting, and I took it off already, but I had it fit on this end right here. And I put a hose on it and put it up to 75 psi, and it didn't leak. So I'm still, even though it doesn't look very good, I'm still comfortable that it's going to be all right. So we got 10 cold water supplies that we can go around the house in. All right. So the next thing is bringing the cold water supply into the boiler itself. Now, here's the diagram on one of the pages. I think it's like page 36 of what you have to do for hot water out, cold water in. And again, it's going to be a mess. Thankfully, these ports are the furthest out to the front of the boiler. So they're not going to be in the way, piping wise, of the boiler supply and returns that we put in. However, they're going to start to cover up some of that stuff. It'd be nice to cover them up as best we can to be able to get that stuff in the back if you have to wrench something, take it off, etc. Have room, but that's going to be interesting. So, but there's a lot of stuff here. And I did make up 2 headers for the hot water out. I'll show you those. So when the hot water comes out, it's going to go to 2 headers, and they're right here. Now I put insulation around them. Looks nice, effective for hot water, but how effective is it? Not really. I really didn't have to do it, but I did it to one, and then I decided, well, this isn't really going to make much difference. What makes me mad about all these fittings here is that here's a union, here's a 150-pound relief valve, here's this 3-way mixing valve, here's a check valve, here's all this stuff. This is all copper, brass, bronze stuff. And as soon as the hot water comes out, it's going to hit all these fittings, and it's going to suck up a lot of heat. Well, that's what I was trying to do with this, was when it came out, it wouldn't suck up as much. It's still going to suck up heat, but it's going to capture it a little bit. So this insulation, to me, now that I think through it a little bit more, is not doing much at all. But that's because there's going to be so much brass and bronze and copper in here. So the idea is all these fittings here are going to make up one header assembly that will be brass and bronze and copper. And as soon as we get to the end of it, like where this valve is, we're going to go back to PEX. It's going to be 3/4 inch PEX that will go out to those 2 header assemblies that we saw. Oh, the other way. Out to these 2 header assemblies. Now, why did I do 2? Again, energy savings. I could have put one long one together, and I thought, okay, if the water comes out of one, when it comes to it, we're not heating up a real long 10-person one that's on the cold water supply. We're just heating up this 4-person one. And if we draw hot water this one, we're just heating up this one. Well, still, it doesn't make any difference because, again, on the side, there's so much heat loss. In fact, it'll probably be as much this little heat exchanger that's in there that has a little bit of water to supply you with water right away. It's probably going to all be sucked up by these bronze fittings, and there's no other way to do it. I mean, you could throw a little PEX in there, but there's just no other way to do it. They got to be in there according to this drawing here. And I questioned this mixing valve. I'll show that to you a little bit more. But I question whether we need that. I'm going to do some research on it. I haven't purchased that yet. In fact, a lot of this stuff here I haven't purchased yet because I'm still researching it to figure out how to do it best. And you might need some feedback from you or some pictures. I actually sent Mara a text just a little while ago requesting pictures of that wall, a variety of pictures and some dimensions, so I can start figuring this out. And I hope I'm not just jumping the gun with you and just doing all this. I mean, hopefully you're not pissed off that I'm setting this all up and maybe you've got completely different ideas, but I don't think you've thought about it that much. But here's your chance to think about it to a degree as far as water piping. So again, I don't know whether we need this mixing valve. Here's a check valve. I guess this probably needed. These are drain valves, things like that. So, but once we get to this, it'll probably be back to 3/4 inch PEX. Now you can see that this connection here is actually 3/4 inch. So once we go out to this PEX right here, there'll probably be a T and we'll go up to the other one. Now, you can see that I've got this one over here and this one over here. Well, this header is not made favorably for us unless we take these headers and put them on the right side of the boiler. So that's a possibility. but I project another boiler in there, a smaller electric one as a backup at some time. So if we put them in the way they are right here, the valves themselves are on the back side. Now that's not terrible, but the valves are on the back side to get this thing. And I want to put these as close to the output of the very close to the output of the hot water heat, so we don't have a lot of 3/4 inch piping that we have to go into before we go into the 1/2 inch piping. So we come out here with just a couple of feet of 3/4 inch pipe going to here, and then it goes out each zone. All right. But if we put them on the wall, now these would be staggered. You see I've got these big hose clamps. In fact, I got them for this one too, that you can hold it onto the wall. This one might be out, let's say 6-8 inches. This one might be out 3-4 inches, so you can get them by each other, etc. So, it's going to be interesting how it actually ends up being laid out. We might make this up towards the ceiling. Well, then we are going to have a long 3/4 inch line back to the hot water supply. But if we get them up towards the ceiling, then we got less PEX, less mess of piping up against the wall. So options there. So here it is again with these two facing the direction that I'm thinking facing, but the valves here they're on the back side. I couldn't. That's the only way I could make it. This end here is all sealed up by the valve manufacturer. The only way to put that, and this has been soldered. I soft soldered this onto the end, 3/4 inch end. So the only way soft soldered on, it's ready for PEX pipe. So that's okay. And here it is again with the second set of clamps that will go on there. Now, this is the water thermostatically controlled water regulating valve. So that's that guy that is this guy right here. And I haven't quite determined whether we need it, whether the purpose is, but you set it so stuff doesn't get too hot. Well, this thing controls the temperature anyways, but I don't exactly know how it controls temperature. You set the water through the display up here to be 100, 110, or 120. It goes up to 132 degrees, I think. But the most that this thing will operate is 120 degrees. So if 132 degree water came through here, what it would do is some of it, it would introduce some cold water in here to supply only 120 degree water out. And that's the hottest that valve can get. And any of them that I found are only 120 degrees. They range from 80 to 100 degrees. But we're supposed to be able to control the boiler at 120, 115, 110. So we've got a control point here, we've got a control point here. Does that make sense? I mean, I'm going to have to do some research on why that's in there. Or is it something, they're saying you need it in the manual. Or is it something that it's got a specific purpose that I'm not seeing yet? All right, so that's that. That's what it looks like. This is a 3/4 inch. They have them in 1/2 inch. They have them 1 inch. We got 3/4 inch pipe. Oh, that brings up a good question. Why 3/4 inch? Well, because you said that these connections here are 1/2 inch. Could go with 1/2 inch, but it's a flow restriction type thing. Trying to get as much hot water in and not lose any pressure. And many of this stuff is 3/4 inch for hot and cold water. When you go look at it, a lot of systems are 3/4 inch, not 1/2 inch. So this happens to be a 3/4 inch. Now there is another one. There's several different kinds of these. This is NPT fittings. You get them sweat fittings, etc. Here's one that's kind of pre-configured with the line going back to the cold water already set up. So I might use this one or the other one. But again, I got to lay it out to see how it actually would all pipe in there. And that's why I'm going to get some pictures. In fact, Mara just tinged me back. Let's see what she says here. Okay, I can do all that when I get home. If I don't send you pics by 8, send you pics by 8, your time, text me. Oh, she's saying text me so she doesn't forget. All right, so I could use that one. Now here's the next thing that's really interesting. Here's a picture. These are called hydronic. These are the valves that go in there at first. And so this is a combination valve that has this port right here is to flush the boiler out. In fact, I found a video that tells you after a year, if you want to get the scale out of it, say you have some buildup of scale, you close this one, you close this one, you open up these two ports, and you pump vinegar through the hot water heat exchanger in the boiler, and you clean the scale out of it. You pump it out through it for about an hour or so, and then you flush it with fresh water, and you're back again. So there's ways to descale your boiler. But what these are is this is what you use on a hydronic, on-demand hydronic heating system. This is kind of a combination thing. So what that does, I'll show you. Come on. I guess I can just. What that does is it takes care of this thing, of this compression fitting. It has this in it, and then it has this drain valve. In fact, this one ends up being up here, which is okay. But it takes a few things and puts them into one fitting. So that's kind of a neat device. I just kind of learned a bit about that today and decided, wow, this is what they're made for. This is what we should be using, is these. I can't decide which ones I'm going to use. There's a different manufacturer. These are smaller, doing the same thing. I actually like these better, but the only way I could get these is to go through Amazon or eBay or something like that, because the stores, well, I can special order them through Home Depot or Menards, but Menards has this. These sets are about $75 for these, and they're worth it. So we're going to have these coming out of the bottom of the boiler where the hot and cold water are. Blue one, cold water. Red one, hot water. Hot water has a relief valve on it, and then you go from there to the mixing valve and things like that. So that's that. Again, about $75. There's the other one. Now here's all the other shit that I shipped you. All this stuff is pretty cheap shit. You can spend a lot more money on it, but I bought cheap shit because you're only going to use. I tested it all out. It all works. I put good batteries in them, took the shit batteries out, and took them out. I got this box backwards. This is the pressure sensor, micrometer, digital one. Oh, here it is right here. I forget what this is. In any event, quite a few gauges. I know you may have gone to Home Depot and purchased your gauges, but this is a 15 PSI gauge. This is a 15 PSI gauge. This manometer, digital, is the same as this one right here. This is the old standard way of doing it. It is this is a gauge only 10 and only goes up to 10 inches of water column. This gauge goes up to 55 inches of water column, which is basically 2 psi. But this is, to hundredths of a pound, and this is a very accurate one also that you'll figure out how to use. Here's a couple of digital gauges. One's 15 psi, one's 60 psi. Just for the heck of it, they were not expensive. One was $17 here, $15 here. reviews on them were so-so. A lot of people said they were good, but a lot of people said they had problems with them. But I decided to give them a try. They look pretty cool. So you could use these gauges on this thing here, which you may have picked up already. Or you could use a combination of gauges. I'll show them to you. Here is a gas leak detector. Again, this was a cheap gas leak detector. I think it was only 26 bucks. It beeps. I see that you can get them at Menards and Home Depot too, but this has got a wand on it. So it picks up propane, natural gas, and as you put things together, run things out to gas furnaces and gas heaters, the stove, etc., you will feel comfortable having this. Now, I hope this survives. This is the second package I sent today. I hope this thing survives shipment because it's not in its box anymore. It comes in a little sack that's in it, but it's at the top of the box. I've had people say this is very fragile. That's this box I sent you is just crammed full of this stuff. But this is the only way I could get it to fit is to put it on top. There's a switch right here that turns it on and off, and then there's a calibration, a sensitivity rotary switch over here. So when you turn this on, you turn it on, there actually one of these lights, it's a warm up. So when you turn on this sensor, there's a yellow light that comes on warming up. And you got to wait for that to go out, which takes about 5 seconds to be able to play with this dial over here on the side that will calibrate it to the sensor. Well, you'll figure it out. You'll read the directions. But I just wanted to remind you that there's a warm up. Okay. I forget what this is. But this is another 15 PSI gauge. Let's go here. So here's the gauge. Now, one thing I don't like about these gauges, I really don't like about them, I don't even know how they'll work. They have short, it's a 1/4 inch. They have very short threads on them. That really stinks. Why couldn't they make it like a bit longer? You know, so it really kind of tells you, okay, if we're going to be using it for a pressure test possibly, are we going to be able to seal it? But I think if you wrap, 4 turns of Teflon tape around it, pipe dope if you want, but be careful, very little pipe dope, you're going to get it to seal. So, it does have on-off button. Turn it on, turn it off. As soon as you turn one of these on, it flashes what PSI it is. So you push the on button, it says 15 PSI, and that's the 15 PSI gauge, and then it goes away to 0. This one, you turn it on, it comes up 60 PSI, and it goes to 0. So that's that. I mean, you could, here's if you wanted to use this 15 PSI gauge on this test port and really monitor it. Or, here's a filter I ran across. I'll come back to this. For 49 bucks, 1 inch in and out, bypass thing to change the filter out. I thought it was a pretty good deal, but I don't know how I'm going to ship that to you. I'd really like to get that to you, but we'll figure something out. I can't ship it. That's too big to go into a flat rate box by USPS. So here's if you wanted to really get funky here. I put some fittings in here. You could put this together, have both gauges. And that's the purpose behind this also. You've got this manometer here and you got this gas pressure test. They're going to do the same thing. You can have one on the input, one on the output, and test it, or you can have them together, see how close they are. I like to play those things. It goes up to 7 inches of water column. Does this one go to 7 inches of water column? That's and when this digital gauge says 10 psi, does this one say 10 psi? It's kind of fun stuff. So there's a way that you could do it. Here's when you turn them on, they light up. And that's it as far as pictures are concerned. So that's what I have sent you in 2 different boxes. So this was in one box with the header assembly. These guys here. But here's what I've got to work on yet. Figure out how the rest of this is going to go together, how this bypass valve is going to go together, how the check valve is going to work, etc. So that's what you got coming to you. The big thing is how we're going to put it onto the board. How is it going to get laid out? And then really particular is, let's bring this in here. Oh, do we want that? No, it's not what we want. Let's go to photos. It would be in Mars. Oh, that's right. Well, what was I after? It's going to be how these pieces actually hang on the boiler. And my thought is that they're going to come out, and as soon as they get to the end of that one fancy valve that you saw, they might go this way. And then this one might go this way or might go this way. But we got to come into the cold water all the way over here and then come out with hot water this way, that way. That would make sense, coming in with the cold water on this side, passing this, and coming out with the hot water on this side, passing that. It doesn't make a hell of a lot of sense, but it could be done that way. All right, that's it for now. I'll send this to you, and we'll talk about it.